Okay, day 3, it says day 2, there's a typo. Day 3, we're going to look at solving systems by substitution. And again, we'll spend 2 days on this like we did for graphing. Warm up, what is the solution to the system of equations graphed at the right? You're looking for your point of intersection, and that would be at 2, 2. So again, solving a system is graphing them and seeing where they intersect. Recall the 3 methods of solving. So we said the first one we spent 2 days on is graphing. And then today we're going to look at our second method, which is substitution. And then lastly, we'll look at elimination. Okay, so today we're looking at the substitution method, and I just kind of wrote these steps out for if you need steps to follow. So for substitution, you're going to solve one equation for x or y. So you want to get x or y by itself, unless one of them already is. You're going to substitute the first expression into the second equation, solve for the first variable, substitute the value of the variable into either equation, and solve for the second. And then you can check your answer. So what we're going to do in the first exercise is take a look, is one solved for x or y, and then where would you plug it in? So if you take a look at these 2 equations, instead of graphing, we could say, hey, y equals 2x. So everywhere I see a y, I'm going to plug in a 2x. So if we rewrote this, it looked like this. X plus 3 times 2x equals 14. And then you would have one equation with one variable. You would be able to solve it. Let's take a look at this one. Here x is by itself, so we would plug this one in for x. Here's what it would look like. 5y minus 3 plus 3y equals 1. So there's the substitution piece. Okay, for the next one, y is by itself, so this is where we would plug it in. For the second one, x is by itself. So we would plug this in for x. For the next one, y is by itself. Plug it in for y. And the last one, y or x is by itself, so you could do it either way. You could stick this in right here, or you could stick this in right here for x. Okay, so how do we actually do it? Okay, so we're first looking at how do you identify what to plug in where, but let's actually do this problem. So Farmer Joe had some chickens and cows. He forgot how many of each he had. Pino knows there are 37 heads and 122 legs. How many of each does he have? Okay, so let's assign an x and a y. Okay, so let's call x, let's see, let's call x, I don't know, just chickens. Oops. The number of chickens, I should say. And then y will be the number of cows. Okay, so here's a system of equations. Let's look at heads and legs. So for heads, chickens have 1 head, so every head for chicken. Cows have 1 head. In total, there are 37 heads. So there's my equation representing heads. And let's look at legs. Okay, legs. All right, so a chicken has 2 legs, and a cow has 4. So 4 legs for every cow, 2 legs for every chicken. Total, there's 122. Okay. So here's the equation. So next step is we have to get x or y by itself. I'm just going to get x by itself. So to do that, I would subtract y from each side and come up with the equation x equals 37 minus y. So now we're going to take that and we're going to plug that in for the x in the second equation. Okay, so get x or y by itself, plug it into the other equation, and I'm kind of running out of room here, so I'll do it here. 2 times 37 minus y plus 4y equals 122. And now we have an equation with one variable that we can solve. So let's do that. Let's distribute this. I should use a different color here. All right, so 37 times 2 would be 74. Let me double check. All right, so we got 74 minus 2y plus 4y equals 122. Let's combine like terms and solve. So we have 74 and negative 2y plus 4y is 2y equals 122. We'll subtract 74 from each side. So we'll get 122 minus 74. We'll get 48 equals 2y. All right, when we solve that, we'll divide each side by 2, and we'll get y equals 24. Okay, so that, if you notice, that stands for the number of cows. So we know that there's 24 cows. So to solve for the number of chickens, we can plug into either equation, so the x plus y equation, or I'm going to plug into this one because, again, x is the number of chickens. So we have x equals 37. We know how many cows there are. There's 24. So I'm going to plug that y as 24, and then we're going to solve. Okay, so we get 13. So here we'll have x equals 13. All right, so let's label it x is 13. This is chickens. And then we have the number of cows. We have 24 cows. Okay, so there's an example of substitution where we have two equations. We plug one into the other, and then we solve. Okay, we got a few more examples, and then this will be what we're going to spend 2 days on this. So we'll try it out today, go over questions tomorrow, and then finish up substitution tomorrow. Okay, so the next one. Solve the mystery number using substitution. So it says the sum of two numbers is 52, and the difference between the two numbers is 38. What are the two numbers? So let's just say the two numbers are x and y. So our system of equations would look like this. X plus y equals 52. The difference between the two numbers, x minus y, equals 38. Okay, so let's solve this. First we have to get x or y by itself. Here I'm just going to add y to each side. So I get x equals 38 plus y. And so 38 plus y. We're going to plug that in. I should put the cloud. Okay, so first step, get x or y by itself. Done. Second step, plug in. So I'm going to take this 38 plus y and plug it in for x into the other equation. So we're going to plug it in there. Okay, so when you do that, here's what it looks like. We have 38 plus y plus another y equals 52. Okay, now we solve. So we have 38 plus 2y equals 52. We'll subtract 38 from each side. We'll get 2y equals, we have 52 minus 38, 14. Divide each side by 2. So we have y equals 7. Okay, we're halfway done because, again, we're looking for a point of intersection, x and y, and we only have y. So now let's plug back into this equation. You can plug back into either equation, but we'll plug into this one. And we have x equals 38 plus, and instead of y, we'll put 7. Okay, because y is 7. And we'll add that together, and we get x is 45. Okay, so if we were to graph these two lines, like we did the previous 2 days, these two lines would cross at the point 45, 7. So these are two numbers that the sum is 52 and the difference is 38. So I can write that as an ordered pair, 45, 7. That is where the lines would cross. Okay, next example, use substitution to solve the following phone problem. Again, this is one we did by graphing yesterday, but we can do the same thing with our systems. So here, plan 1 was when we added these two together and we found it was 99, let's see, 40, 55 plus. Okay, so it was 96.667 per month. And the other equation, we spent $1,000 on the phone, it's 55 per month. Okay, so here y is already by itself, so you can just plug it right in here, and it ends up setting them equal. We want to see where these two are equal. So we have 96.667x equals 1,000 plus 55x, and then we solve. So here I'm going to get x on one side. I'll subtract 55x from each side. So we get 41.6 x equals 1,000. Divide each side by 41.667. When we do that, we get x is about 24. So I'll round. And that's what we got yesterday, at 24 months. So then at 24 months, again, x was time, how much would it cost? You can pick either equation to plug into. So I'll just plug into the top one here, and we'll do 96 0.667 times 24 to see the cost of that. So 24 times 96.667. So again, our total price, which we solved yesterday, $2,320 and some odd cents. Okay, so again, we graphed these two lines. This is where they cross. This is the solution. But now we did it by substitution. Okay, so 3 more examples. Okay, so again, first step, get y by itself, which is done. Second step, plug it in. Here's what it looks like. Negative 5x minus 5, plug in 15 plus 8x equals negative 30. Okay, now we have just x's, so we can solve. So we'll have some distributing to do, but leave the negative 5x. And then we distribute the negative 5. Negative 5 times 15 is negative 75. Negative 5 times 8x is negative 40x. And that equals negative 30. We'll combine like terms. So if we add our x's together, we get negative 45x. Let's add 75 to each side too. Okay, so that's 45. Okay, let's get rid of the negative 45. We'll divide. So x equals negative 1. Okay, so again, we're looking for the point of intersection. We only have half the answer, so now we just take this and plug it into either equation. Usually there's an equation that's easier to plug into, and it's the one where y is already by itself. So let's plug in. We get 15 plus 8 times negative 1. All right, so that's 15 minus 8, so y equals 7. So these two lines do cross, and they cross at the point negative 1, 7. Okay, another example. X or y is not by itself, so first step, get x or y by itself, so I can subtract 3y from each side, and so we get x equals 1 minus 3y. Next step, plug in. So we're going to take this guy and plug it in for x, and so when we rewrite it, it looks like this. Negative 3, parentheses, 1 minus 3y minus 3y equals negative 15. Okay, now we distribute, combine like terms, and solve. So we'll get negative 3 plus 9y minus 3y equals negative 15. Okay, combine like terms, and I'll also add 3 to each side. So we have 9 minus 3, 6y equals negative 12. Divide by 6, y equals, so y equals negative 2. Last step, pick an equation to plug into. I'll just plug into this equation right here, plug in for y. So we have x equals 1 minus 3 times negative 2. So this is 1 plus 6, which is 7. So x is 7, and that means that these 2 points, they cross at negative 2. Oops, sorry, 7 comes first as x, negative 2. There's your point of intersection. Okay, last one. Get x or y by itself. Here we can get y by itself. Y equals negative 3x, and you'd add 5 to each side. Next step, plug that in. So we take this, plug that in to here. So we have 5x minus 4, parentheses, negative 3x plus 5, and that equals negative 3. All right, let's distribute, 5x, and then distribute. That would be plus 12x minus 20 equals negative 3. And so you would have 17x, and you would add 20 to each, equals 17, so x is 1. All right, plug back into this equation, y equals negative 3 times 1 plus 5, which we're getting from here. And so y would be 2. And so these 2 points would cross at 1, 2. All right, so that was day 1 of substitution. We'll take a look at that again tomorrow.